So welcome guys, here we are now in chapter 12. So chapter 12 is all about sequences and series. So our focus today is about the introduction to sequences. So you're expected to learn how to write rules for sequences and along with that listing terms of a given sequence. Okay, let's begin first with some definitions. When we say sequence, it is an ordered set of numbers. So this is represented in a set notation. So using the braces symbol. And the term of the sequence is a number in the sequence. So the elements inside this symbol are the terms. And sequences can be either finite or infinite. When you say infinite sequence, this is a sequence that continues without end. For example, we have 1, 3, 5, 7, 9. And as you can see, I put 3 dots, those are ellipses. And those 3 dots would denote that it's an ending. And we have finite sequence. By contrast, it is a sequence that has limited number of terms. So basically, an example is like this: 1, 3, 5, 7, 9. And as you can see, there are only 5 elements in this particular sequence. Okay, sequences can take 2 forms. It's either recursive or explicit. We're going to start with what recursive is. So when we say recursive formula, this is a rule in which one or more previous terms are used to generate the next term. You will see that in this particular formula, you will see a sub n minus 1, a sub n minus 2, those things. That will denote that it is a recursive formula. For example, let's try this one. Find the first 5 terms of the sequence with a sub 1 equals 5. And the rule of the sequence is given by a sub n equals a sub n minus 1 plus 1 for n greater than or equal to 2. Okay, let's do that. A sub n equals... What does this notation means? This means this is one term prior to this one. So it means this is the previous term. So the first term is given, so a sub 1 equals 5, so that is the first term. So what we're going to find is the next term, so we got a sub 2, a sub 3, a sub 4, and a sub 5. Again, the subscripts here are the values of n. Let's begin with a sub 2. So we got, this is n, so 2 minus 1 plus 1. And 2 minus 1 is 1 plus 1. And a sub 1 happens to be equal to 5. That gives us 5 plus 1 equals 6. So a sub 2 is equal to 6. Let's go to a sub 3. So the value of n is 3. So we got a sub 3 minus 1 plus 1 equals 3 minus 1 is 2. So we got a sub 2 plus 1. And a sub 2 is equal to 6. So 6 plus 1 equals 7. So a sub 3 equals 7. Next, a sub 4. The value of n is 4. So that is 4 minus 1 plus 1. That's a sub 3 plus 1. So a sub 3 is equal to 7 plus 1 is 8. And a sub 5. So n is 5 plus 1. So a sub 4 plus 1. And a sub 4 is 8. 8 plus 1 equals 9. So here we go. We have the first 5 terms of that sequence. First term is 5. Second term is 6. Third term is 7. Fourth term is 8. And the fifth term is 9. Okay, let's go to the next example. Okay, next. Find the first 5 terms of sequence with a sub 1 equals negative 5, and this is the formula. How would we know if it's recursive? This symbol, this notation would tell you that it's recursive. Okay, so every time you see this, like similar to this one, that will tell you that this is a recursive formula. Okay, we're gonna list again. A sub n equals minus 8. Again, this one means one term prior to that one that you're looking for. So basically, this is the previous term. So we have a sub 1, which is negative 5. So we're going to find a sub 2 until a sub 5. So a sub 2 means n is 2. So 2 minus 1 minus 8. So that is a sub 1 minus 8. And a sub 1 is equal to negative 5. So negative 5 minus 8, that's equal to negative 13. So a sub 2 is negative 13. And doing the same process, so we will get a sub 3 is a sub 2 minus 8. And a sub 2 is negative 13 minus 8. That's negative 21. Same thing with a sub 4. So that is a sub 3 minus 8. A sub 3 is negative 21 minus 8. It's negative 29. And a sub 5 is a sub 4 minus 8. And a sub 4 is negative 29 minus 8, which is negative 37. There you go. We have our 5 terms. The first 5 terms of the sequence: negative 5, negative 13, negative 21, negative 29, and negative 37. So it's your turn. Your turn. First, find the first 5 terms of that sequence with a sub 1 equals 2 and a sub n equals negative 3 times a sub n minus 1.